All right, so chapter 5. Algebra. Yay and O's from various parts of the crowd. We do need to know a little bit of algebra to deal with our business math, and so we have to get a little bit of an introduction to it. Now, when you're dealing with algebra, we need to have at least a little bit of an introduction to some terminology. Constants. Constants, folks, these are numbers. So constants are things like 4, 0, -2, 3.5, right? Anything that is just a number, okay? And you can have weird stuff like 4.1 repeating, right? I mean, these are all just numbers, all right? And mathematicians will call them constants because we're nerds and we want to give them a term that represents all of them grouped together, all right? So, constants. Once you get into algebra, you have to work with variables. Variables, these are unknowns. These are things that you need to figure out, or someone needs to tell you what they are, okay? And you will then utilize them to figure things out, okay? Now, mathematicians, when we deal with variables, what's our favorite way of describing a variable? X, yes, folks. X is our favorite variable. You can use Y. Y is perfectly good. There are 26 letters in our alphabet, folks. Feel free to use whichever one makes you happiest. If X and Y gives you the creeps because it seems like it's algebra and using W and O would work better, go ahead. Just be careful when you use letters like O. What does O often look like? 0. That makes life tough, okay? That's why a lot of times X isn't always used in algebra, because when we do times, it looks like the times symbol, right? And what mathematicians have done throughout time is said, screw you, you have to use X. Sorry. Now, again, like I said, you can use any letter that you want. You can slip into foreign letters if you would like. You could use, say, Greek symbols, right? This is a phi. You could use, a sigma. You don't have to stick with English, right? If you know some foreign languages and using foreign characters would work better for you, go ahead, right? Nothing wrong with it. In addition, what I like to tell students is that, it doesn't have to be one letter, okay? You can use whole words as a variable, okay? So me is a perfectly good variable. You just have to be careful that you don't think of me as the variable capital M and the variable little e, okay? But if you're doing a problem where me and Steve are out, shooting ducks, right? And you want to have a variable to describe me and Steve, you may create a variable called me. And you could create a variable called Steve. There's nothing wrong with it, okay? The reason why mathematicians don't tend to do this, though, is that we're lazy, right? We want one letter because then we can't misspell the word me, which can happen on a bad day for me. So I will tend to use X and Y, folks. You don't have to, okay? There will be times where I specifically try and force myself to use variables that are not X and Y, but more times than not, that's what I'm going to do, okay? So just bear with it, okay? Now, so we have constants, we have variables. Guess what we can do with those two things? We can put them together, woohoo! All right? And usually when we put constants and variables together, we put mathematical operators in between them. That sounds really... Mathematical operators. Whoa! This is like a really, really smart guy who's on the other end of the phone who can read your mind and dial the number for you, because they're an operator, Okay, what are our mathematical operations, folks? Parentheses, exponents. What else can we do? Multiply and divide, add and subtract. Mathematical operators are just math, folks. I mean, it's a fancy way of saying put some plus signs and some minus signs and some division signs and some multiplication signs in and around your variables and constants, okay? So these three things make up algebra. So the simplest way to put all of these things together creates what we call expressions, okay? Algebraic expressions, if you want to be specific. But the idea here is that algebraic expressions are just numbers, variables, constants and variables with mathematical operators in between them. Like this really scary one. That's an algebraic expression, okay? Now, right now it is just an expression. You could, if I asked you to, evaluate this expression. When you're asked to evaluate an expression, what do? You essentially solve it. What is 2 plus 4? 6. You can get a specific one-number answer, so to speak, when you evaluate this expression. Now, other expressions aren't quite so easy. You may have variables and constants floating around. If I told you to evaluate this expression, what would you say? It's just x plus 2. Because I didn't tell you what x is. You don't know what x is until I tell you. Okay? If I tell you to evaluate this expression when x is 3, what do? You take x, you substitute in 3, and then evaluate 3 plus 2. And say it's 5. Okay? Folks, what you have done right there when you did that was perform the most complicated algebraic expression solving that you can do. Okay? This is something that people who have cognitive difficulties can't do. Right? If you guys have seen like Rain Man or the movies where you have autistic people who can multiply 8-digit numbers together and get an answer without thinking about it. But if you ask them, you know, you spent 25 cents on a candy bar and 50 cents on a pad of paper, how much money did you spend? They wouldn't be able to do it, right? Because they don't know how to process information and utilize variable substitution, okay? And really that's algebra's job, is to give you that abstract thought of, I have something I don't know, how do I plug something into it that I do know to then generate a result? You think that's something that's not complicated? It really is, okay? As a child, you know, when your brain is still mushy, when you start figuring this stuff out, it's what makes your brain solidify because it creates so many possibilities, right? When you think about x plus 2, how many answers could there be? Yeah, an infinite number of them. As soon as you have to, as a child, start contemplating infinity, that's good stuff, okay? This is what forces your brain to start growing, right? Creating more dendritic connections inside of your head because it provides you an understanding of something that is way deeper than anything you've captured before, okay? Sometimes we just have to recreate those connections in your brain, okay? Obviously, you can have expressions that are nasty, right? Whatever, with lots of different constants and or variables floating around in it. One thing that I like to point out to students, this 2 out in front of the x, what does that mean? Times, right? In fact, the fact that all of these letters run together, I'm really saying, what am I doing with all of these variables and constants? Multiplying, right? Again, that's a way that you have to be able to think when you see letters run together. That's why it's sometimes scary to use variables like this, because you think M and E are really being multiplied by each other instead of the one variable me. All right? So, what number is multiplying this variable? 1. Why 1? When there's nothing in front of it, there's really a 1. Well, why, if there's nothing in front of it, isn't it nothing, which is 0? The identity property of multiplication, right? 1. When you multiply anything by 1, it doesn't change the number, right? So when you write the variable x, is that x is the same as 1 times x, all right? It's not something that's overly deep, but at the same time, if it helps you to write the 1 in front of your variable so that you remember there's a 1 there, please do so, all right? It can make life easier sometimes. Okay, so those are expressions. What do you note is missing inside of all of these expressions? An equal sign. When we create an equal sign, or when we add an equal sign, our expressions change. They become equations. And equations have an equal sign. Equations can also have a true or false value associated with them. Because 2 plus 4 equals 2? Yeah, no. That would be called a false equation, all right? So when you have expressions, one of the things that you commonly do with them is evaluate. When you have equations, one of the things that you commonly do with them is to solve, okay? What number, when you add 2 to it, do you get to 3? 1. You have solved for x, okay? Equations, folks, those are generally formulas, all right? Once you start getting into equations, the whole point of working with equations is that they will base how you create formulas. And formulas are a representation for solving values. So what kind of formulas do you guys know? Well, okay, but what would that represent? Something that's a real formula. So how would you figure out the area of a circle? Does anybody remember the area of a circle formula? The area is pi r squared, right? Pi times the radius squared. Here, this formula is a way to represent how to calculate area, right? Because the area is pi times whatever the radius of your circle is squared, right? Standard way of calculating the area of a circle. Now, how do we calculate the formula of how much we owe when we buy something? Well, let's suppose I buy 6 ounces of sugar. It costs 25 cents per ounce. How do you write the formula that represents how much I owe? 6 times 0.25. How would you write that as a formula where you don't know how many ounces I bought? Exactly, right. So my bill is going to be x times 0.25. And note how I wrote times, right? One of the things that you got to get used to when you're dealing with variables is different notation, okay? Multiplication is the one that causes the most problems because there's lots of ways of writing it, right? We can write 2 times 3. 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 All of those things are the same 2 times 3. Okay? In general, this is an okay formula. The way most mathematicians will write it, just so that you know, is like that. They will tend to put the variables after the constants. It's just common practice. Okay? You don't have to, but you do want to kind of try and get into that habit, because when you start playing around with more complicated formulas, this pattern is what's going to be used, and you kind of want to get used to it so that you don't potentially make a mistake. All right? All right, so we have expressions, we have equations. So normally I would spend more time on this, but since we don't have as much time as we would like, let's just jump right into it. All right, so we need to be able to solve expressions. All right. Solve for x. 3. How? Very good. Subtracting 1 from both sides. Please note that when you are solving for a variable, what you do is you do a balancing act. All right? This is my process for going through solving for variables. If you have other processes that you have used before and are comfortable with, don't worry about using your own technique, okay? What I like to do is to say, I need to get my variable by itself. That's your goal. To get the variable by itself, I need to remove this plus 1. How do you remove a plus 1? You subtract 1. If you subtract 1 on one side of an equal sign, you must keep it balanced. Subtract 1 from the other side as well. So what I will often do is right underneath my equation that I'm solving, I write -1 equals -1, because that's a nice, good, true statement, right? And then what you do is you just add the two statements. Add the left-hand side and add the right-hand side. Because when you take x plus 1 and then subtract 1, what are you left with? X. When you take 4 and add a -1, so yeah, you guys looked at that and probably said, okay, I know it's 3. Okay, then that's good. But you need to be able to explain why, all right? And getting in the habit of being able to do this will make sure that you don't screw it up at a later date when this gets nasty, okay? I'm just setting the groundworks for right now, okay? That's dealing with addition. You will also have subtraction. How do you undo subtraction? You add, and again, the goal here, folks, is to get x by itself. Right now it's not, it's got a -4 next to it. So I know I need to add 4 to get rid of that -4. Again, if I do it on one side, I must do it on the other. And again, I write this bar here to indicate I am now performing that operation. Right? X -4 plus 4 leaves me with just x. 3 plus 4 gives me 7. X is 7. We have solved. Again, when you have solved, please check and make sure it's right. Take x equals 7 and put it in for x up here. Substitute it in. What is 7 minus 4? 3. Okay. All right? Never hurts to make a quick check when you are dealing with these. So I have addition and subtraction. Guess what I'm going to do next? Multiplication. 4x equals 3. How do we undo multiplication? Division. Right? Again, we want the x by itself. It's not alone. It's got a 4 out in front of it. It's being multiplied by it. Right? Remember, this notation indicates that 4 is multiplying by the x. Technically, we need to divide by 4. And if I divide one side by 4, I must divide the other side by 4. 4x over 4. If you have 4 x's and you divide them into fourths, x. That's the whole point. What's 3 divided by 4? You could write it as a decimal. There's nothing wrong with telling me this is 0.75. If I told you I wanted it to be written as a fraction, though, how would you write it? Exactly. You would write it as 3/4. Just be careful with those sorts of things. Make sure you answer the question the way I have asked. Okay? And again, also read for how I asked you to round it. Let's suppose I told you to round this answer to the nearest tenth. How would you answer this question? 0.8, right? Because 0.75, here's the tenths. Go 1 to the right, that's a 5. You need to round up. This is approximately 0.8 if I asked you to round it to the tenths. All right? Again, read directions. As a side note, just so that you've seen it potentially, there will be times where I'm going faster than I normally am, and this is another way that I will often write divide by 5 on both sides. I will just use a fraction sign, because that's exactly the same thing, right? You guys know that fractions and division, they're basically the same, right? So writing this or writing this over 5, it's the same thing. If you have done this in the past, that's cool, all right? By all means, continue to do it. X is 2. And again, please check and make sure, right? For every answer you get, always think, well, if I have 3/4 and I multiply it by 4, what am I going to get? Okay, I'm going to get 3. So, suppose I have division. How do we undo division? Multiply. Again, note all of this stuff that we're doing. We're undoing what's being done to the x. That's our goal. And however you want to write it. Again, this is one of those weird things where I don't, however you would like to write multiplying by 5 so that you know in your brain and you know how to tell me what you're doing to both sides, that's cool. All right? Note I tried to use a little x. Why did I use a little x? So I didn't confuse it with the variable x, right? If you want to do this instead, use a dot. That's fine too. Again, though, what's wrong with a dot? Yeah, it's real easy to confuse it with a decimal point. So a lot of times this is what I will write just so that you have seen the notation. I'll put the 5 in parentheses to indicate I'm multiplying, because to me, when you see parentheses, usually there's a number out in front of it, and that means multiplication. Again, whatever works best for you, I'm okay with. Just be careful. And note, when I do an operation, that's when I write these lines underneath, telling myself, do a calculation. Okay? Here I'm dividing by 5 and then multiplying by 5. The whole point is getting the x by itself. Here, what's 3 times 5? 15, and again you check and make sure what's 15 over 5? 3, okay? So these are the building blocks of solving algebraic equations, okay? All right, so what happens when we start to put some of those together? All right, here's where it starts to get at least a little bit more complicated. Potentially you can look at this problem and solve it in your head, and that's cool, right? And usually when people are solving this problem in their head, they're doing it by a process of elimination. They're like, what should the number be? What should x be? Well, it should probably be 2, 3, or 4, and I'm going to plug 2, 3, or 4 in there and see which one works. That's an okay way of solving algebraic equations, folks. There's nothing wrong with it. But the process is really best done using these techniques. All right? Now, the key here When you have a mix and match of addition, subtraction, and multiplication and division, you should always undo addition and subtraction first, then undo multiplication and division second. That should really always be what you do last. All right? You don't have to do this if you have used problems in the past where you undo multiplication and division first. That's fine. I don't mind, just as long as you do it correctly. All right? But we need to get the x by itself. Right now, it's got a 2 multiplying it and a 1 adding it. My advice, undo the addition and subtraction first. How do you undo the plus 1? Subtract 1. And again, if you do something on one side, you must do it on the other. There's my bar indicating I'm going to perform some algebraic expression solving. So I add the 1, subtract the 1, they go away. 7 minus 1 gives me the 6. I'm not done because the x is not alone. It's got multiplication with it still. Undo that. Divide both sides by 2. Again, I give you a large bar to say I'm doing some performing. X equals 3. And again, you plug x equals 3 back up into your equation and make sure it's true, right? 2 times 3 is 6, plus 1 gives you 7. And again, you had to perform your order of operations to make sure you did that correctly, right? You didn't do 3 plus 1 first, right? Because if you did 3 plus 1 first, you'd get 4 and multiply it by 2 and get 8. But you guys know that multiplication comes first. That's why you did the 2 times 3 first, got 6, and added 1 to get 7. All right, so these sorts of order of operations things that a lot of times you guys just sort of do, think about it, right? I mean, it's there so that you don't screw these sorts of things up. Be careful with them, all right? All right, so let's this is where it starts to get a little bit more difficult to be able to do it in your head, right? But again, the idea here is we need to get the x alone, undo the addition and subtraction first. This is subtraction. We want to undo it. If you do it to one side, you must do it to the other. Plus and minus, the whole point is to get rid of that. 5 plus 4 is 9. Please be careful. And don't tell me that the answer is 3. Because a lot of times students will look at this and say, oh, well, I'm dividing by 3. Great, 9 divided by 3 is 3. Perfect, the answer is 3. No. What do we need to do to get the x by itself? This is division. To undo division, we need to multiply both sides by 3. When you're dividing by 3 and then multiplying by 3, they cancel each other out. We're left with just x. 9 times 3 is 27. And again, check your answer, okay? And in fact, if you really want to get carried away, and I love it when you guys get carried away, usually, take this, plug it back in, and prove to yourself that it's true. So take 27 and plug it back in to the very beginning of the equation. Write in 27 over 3 minus 4 equals 5. Is that a true statement? Why?
27 divided by 3 is 9 minus 4 is 5.
Exactly. We do the division first. Then we do the subtraction. Once you get left with a number equals a number and those two numbers are the same, that's the yay moment, right? That's when you put a big check mark here, and if you're standing up doing the problem, that's where you do a little happy dance. Checking answers should make you happy, because if you get the right answer and the two numbers are the same, it's joy, right? It is. And it's okay to be happy about it. Smile. It's math. You don't get to smile very often, so take advantage of it when you can. Dancing hopefully makes you happy. Dance if you have to. It's okay. All right, now. One of the other things that you have to be able to do in algebra is combine like terms. When are terms liking each other? That's a little creepy, right? All right, very good. So it's really based on those first initial definitions I gave you in the beginning, right? Constants are like. Variables are like. If your constants and or your variables are the quote-unquote same, you can combine them. So if I give you 2 plus 3, what do you guys normally do with that? We combine them and make it 5, right? Please do that. All right, so if I give you this equation, right, if I say 2 plus 3 plus x equals 6, what's the first step? Add the 2 and 3 and tell me that it's 5, okay? When you are combining terms, normally when I'm combining terms, I don't give you a bar underneath it telling you that I'm doing it. I just do it, okay? 5 plus x equals 6. Note the x is not by itself yet, right? It's got a 5 plus in front of it. How do I get rid of that 5? Subtract 5. Please be careful. And note how I write the minus 5. I write the minus 5 underneath the plus 5 so that I know that's what I'm going to work with, right? When I was over here, I was writing the negative 1 right underneath the plus 1 because I knew those were going to go away. It's perfectly okay to write it over here. Negative 5 is negative 5. All right? Now, do the performing operation, right? Because if you plug in x equals 1 back up here, what is 2 plus 3 plus 1? You give it a big check mark, and then what do? And accentuate however you need to, right? I mean, this one was pretty easy, though, so your dance should be kind of subdued when you do that one. So when you get to the harder ones that you know, your dance should involve some motion. All right? And I tell my students that dancing in class is always worth extra credit. So if you ever want any extra credit in this class, come on up, do a problem, and when you do that problem, and you check your answer, dance, and you'll get extra credit. I don't expect any of you to do it, but on the off chance that you do, it's okay. Now, we know how to combine constants. Why is it 2x? It's 1x plus 1x, right? Remember that the number sitting out in front of this x is a 1. That's why I told you back earlier that when you write down variables, remember that it means a 1 in front of it, right? So if you have 1x and you have another x, you add them together, you have 2 x's. So if I give you x plus 4x, how many x's do I have? 5, okay? Because 1 plus 4 is 5. Okay? And again, when you are doing your algebraic solving, combine any x's that you need to. Okay? So if I give you x plus 2 plus 2x equals 11, and I ask you to solve for x, now we're starting to get to spots where doing it in your head, getting a little tougher, okay? So your first step, before you go solving an equation, look and see if you can combine any terms that are the same, all right? In this instance, I can't combine any of my numbers because the only constant I have is 2 by itself. But I can combine the x and the 2x. To tell me that I have 3 x's, because 1x plus 2 x's, right? I like to point out in my classes that if you have 1 x and you add 2 more x's, you might be a little bit more choosy when you get married the next time. 3 x's is a lot of x's. Anyways, just be careful with it. And once you get everything combined, now start applying our rules we had to do before. Undo your addition and subtraction first. We need to subtract 2. If we subtract 2 from one side, we must subtract 2 from the other. We have multiplication. Undo the multiplication with division. And again, check your answer. And honestly, folks, you really want to check it back at the very beginning, okay? And when you're doing this, it's usually a good idea to switch colors so that you don't get your check and your solved, right? I strongly encourage multiple colors on homework assignments, just because then it's more colorful, right? I mean, math, folks, is boring more times than not. Make it more exciting by making it colorful. Try not to use red, though, because red is how I grade usually. So green, purple, blue, black, all those are great, right? But whatever. Again, everywhere you see an X, substitute in a 3. Be careful when you substitute that 3 in, right? 3 plus 2 plus 2. Now, how should I write 2 times the 3? Yeah. Don't just write 2 and then write the 3, because what does that look like? 2 times 3 is not the same as 23, usually. What do I do first up there? Multiply. I do the 2 times 3 first. Don't just tell me that this is 3 plus 2 is 5 plus 2 is 7 times 3 is 21. Grrr. That will make me sad. All right? You know to do the multiplication first. 3 plus 2 is 5 plus 6 is 11. You give it the check mark, and you do a little happy dance. Whatever you want to do, okay? And yes, this is videoed and will be out on the World Wide Web for people to watch. Hey, if it works, go for it. Okay, so combine like terms. All right, now. Let's suppose that I give you 2 plus x minus 4 plus 4x equals 6 minus 1. It is okay to combine multiple stuff at the same time. Just be careful. All right? My advice is to combine x's first, because usually that's easier. Usually not a guarantee. I have 1 x's, I have 4 more x's. I have 5 x's. Two minus 4 is a negative 2. And you can write it as minus 2 or you can write it as plus negative 2. Either of those are perfectly okay. But just be careful with this. Don't do 2 minus 4 and wind it up being plus 2. Okay, that tends to be what happens with my students, is that this becomes a plus 2 for whatever reason. And that's just you being lazy. Don't be lazy. All right? And what's 6 minus 1? 5. Once you have everything combined, now start applying the rules. Okay? How do I undo subtraction? Plus. All right? This is multiplication. I need to get that x by itself. Divide by 5. I'm perfectly happy with 7/5, folks. That's a great answer. Again, any of those are viably correct answers. Just make sure you read the directions and answer the way I ask you to. All right? All right. So, not bad. Okay. What's different about this equation? Do, do. Right? I mean, it's scary when there's x's on both sides of the equation, right? You need to get all of the x's on one side. Okay, so when we were dealing with this equation right here, essentially what we were trying to do first was get all the numbers on the other side of where all the x's were. That's kind of your goal. The problem, though, is that before you start this problem, you need to get the x's all on one side first and then get all the numbers on the other side. Does it matter which side the x's are and which side the numbers are? No. My advice to you, though, is work with the x's first and make sure that your x's wind up nice. All right? If I've got 2 x's on one side, how would I get rid of these 2 x's to the other side? How do you undo 2 positive x's? You would subtract 2 x's, right? So one way to do this would be to subtract 2x from both sides. Why might I choose not to do that? Yeah, because what ends up on the right-hand side when you have 1x and you subtract 2 x's? You have negative 1x's. Basically, you put away 1x to shoot that person later. Which may not necessarily be a bad thing. It's always good to have an x in the hole. But instead, what might you do? Just subtract the 1x, because when you subtract 1x from 2 x's, how many x's do you get left? 1, and it's a positive x. There's no negative sign screwing you up. All right? Again, another one of those things about this class that tends to throw students on a loop are negative signs. They tend to just disappear for you guys. That would be bad, okay? Negative signs are important. Again, it's dealing with debt. So in this case, I advise you to subtract an x from the right-hand side. And if I subtract an x from the right-hand side, I got to do it to the left. And note where I write my minus x so that I'm careful. I write it underneath my x's so I don't accidentally write it under the 4 and do 4 minus x and say, oh, I've got 3 because 4 minus 1 is 3. That's one of the other common mistakes that I see in this class, is that you combine terms that shouldn't be combined. Okay? X's can only be combined with x's, not with constants, unless you're paying child support or alimony. And then your x's have some constants. All right, so The key here, though, is getting all of the x's to one side or the other. If I have two x's and kill one of them, I only have one left. Don't lose the 4, right? You don't kill all of your children when you kill one of your exes. They don't go away. Kids never leave, as evidenced. Keep your constants when you are combining your x's. When you get rid of an x, be careful. Again, the classic student mistake here is to say that this equals 7. It's -7, right? There's a minus sign in front of that 7. Don't let it disappear. Some of you are going to do it. 25% of you, even though I've told you, are still going to do it. Don't be that person. This is -7. I still need to go again because I still don't have my x's alone. I've got a +4. How do I get rid of a +4? We subtract 4. If I do it to one side, I must do it to the other. Again, please be careful with negative signs. Let's suppose, now I know that this is a mistake, but let's suppose that you look at this problem and you say, oh, 7 minus 4 is 3. And you're smart with your minus signs and you say, oh, but -7's bigger, so therefore this should be -3. I know this is wrong. Don't write it in your notes. But let's suppose you accidentally say this, okay? Because you know 7 minus 4 is 3. I'm good. What am I going to do next? Check my answer, okay? I'm going to come back up here, and I'm going to say, okay, plug x is -3 in. Be careful with it. 2 times -3 plus 4 equals -3 minus 7. What do I do first? Multiply. What's 2 times -3? -6 plus 4 equals -3 minus 7. What's -6 plus 4? -2. What's -3 minus 7? And this is where you say, fill in the appropriate word for crap that you use. Right? This means that you did something wrong. That's why you check your answers. There's no happy dance here, folks. There's just a sad face. Right? That means go back and check your answer to see where you went wrong, okay? So here you will go back and you'll say, wait, minus x. No, that's definitely right. I didn't lose my minus sign. Good, good, good. -4, -4. And then you say, oh, wait a second. Now I see my problem. That -7 minus 4 is not -3. When the signs are the same, I add the numbers. This should really be -11. And you say, whew. Okay? Are you done, though? No, you still check your answer, okay? Except now you're going to check it with a different color because your first one screwed you up, right? But now you're going to go, okay, here we go. 2 times -11 plus 4 equals -11 minus 7. Again, you're careful, do your multiplication. Now do your addition and subtraction. -22 plus 4, -18, -11. Yes! You give it the check mark, and you get to do an extremely happy dance, right? Because now your check worked, and you're pretty happy that the solution is x equals -11, all right? This is why you check your answers. Because let's face it, folks, when we're doing math, more times than not, we're doing it too fast to just get it done. All right? This is what stops you from screwing it up when you do that. All right? All right, so now, the last thing we need to do before we start playing with word problems, Word problems are the goal, folks. Parentheses. What was that? Distribution, or the distributive property. When you are solving equations where there is a parenthesis, distribute. Get rid of parentheses before you solve. All right? So the true first thing that you do when you're going to solve things is really this. If there are any parentheses within your problem, do your distribution, then apply your solve. Now, how do we distribute these things? How do I distribute a 2 through the x plus 1? The way I like to show students this is to do it without x's first. What do I do first up here? You do the parentheses first, right? When you're evaluating, do your standard order of operations. You're going to do 1 plus 2. What's 1 plus 2? 3. Once you do that, then what are you going to do? Multiply by 3. 3 times 3 is 9. Okay, so the answer to this is 9. If you think of it in terms of the distributive property, the 3 multiplies everything inside of the parentheses. What's 3 times 1? What's 3 times 2? Please note that it multiplies everything in the parentheses, okay? What tends to happen to students is that I will see, oh, this becomes 2x plus 1 equals 8 without the parentheses in there. Distribute. Be careful distributing, okay? So the 2, and if you want to draw the arrows, I strongly recommend them. There's nothing wrong with it. Put them in there. This is 2x plus 2 equals 8. Now apply your rules. Subtract 2 from both sides. Divide 2 on both sides. And see that x is 3. And this is one of those where you really don't have to check it. You just observationally check it. 3 and 1 is 4 times 2 is 8. Good, right? When it's too easy, happy dance is an overkill. All right, so this really gets me to the ultimate algebraic equation. Uh, 3 times x plus 1 minus 2 times x plus 2 equals 8, whatever. All right, now before I dive into this problem, I want to do a side problem. If I asked you to evaluate this expression, what would you do first? You do the parentheses first, right? You do 2 plus 1. What would you get? 3. What would you do next? 4 times 3, 12. What's 16 minus 12? 4. Okay? Now, what happens if I ask you to do this using the distributive property instead? Right, we do 4 times 2 and 4 times 1. So it's 16 minus, what's 4 times 2? 8. Plus, what's 4 times 1? What's 16 minus 8? Plus 4 is 12. So 16 minus 12 is 8. Huh? Why is this wrong? Because it's a negative 4, right? This minus sign, when you distribute the 4, it comes along for the ride. Don't let that minus sign miss the ride, right? This is not 16 minus 8 plus 4. It's 16 minus 8 minus 4, because technically when you distribute all of that, okay? So, with that in your arsenal of brain power, how are you going to distribute here? This one's perfectly fine. It's 3x plus 3 because the 3 is a nice good old positive 3. Yes, be careful with this too. Distribute all of it. And I strongly recommend anytime you have parentheses and a number outside of it that's got a minus sign, circle the booger. Do it, right? This minus sign is a classic lost minus sign problem waiting to happen, right? This is minus 2x minus 4. Classic student mistake that becomes minus 2x plus 4. So step 1 in any algebra problem is distribute away parentheses, right, when you're solving. Your next step after you distribute, what do I got to do with this stuff? Combine the like terms. I have 3 x's, I knocked 2 of them off. I got 1 x left. 3 minus 4. Be careful with that, all right? Now you've got it into a nice straightforward problem. Add 1 to both sides. X is 9. And what are you going to do when you're done? Check it. Okay. So, 3 times 9 plus 1 minus 2 times 9 plus 2 equals 8. One of the other things we do, or the other reason why I like to ask you to check it, is that it keeps your brain versatile. When you are solving, you undo distribution first, right? Or you do your distribution. When you are evaluating, remember this is just do stuff in the parentheses first, then do your multiplication and division, then do your addition and subtraction, right? So it keeps your brain flexible so that you can flop back and forth between the two, right? You're going to do the 9 plus 1 first, and then the 9 plus 2 second. Do your multiplication. 30 minus 22. And again, happy dance. All right? All right, we did not make it to any word problems, which is kind of unfortunate. Please note that we have a test next week on Wednesday. All right? Normally, Monday is set up to be review only. We didn't quite get through all of Chapter 5 yet, so on Monday we are going to finish Chapter 5 and then do as much review as we can after we finish up Chapter 5, okay? The homework for Chapter 5 is still the evens at the end, 2 through 40. It's only 20 problems, but a lot of those are word problems, so if you would like to take a stab at them, please do. Again, the word problems can be problematic. We'll get to those. So we will have, the homework officially is not going to be due on Monday, right? Questions on it after I do the standard lecture for Chapter 5 word problems, okay? So next week, Monday, try to be here as early as possible so that we can get through as much as possible, because you're missing out on stuff because of Monday's cold.